Our interviewee today for the oral history collection at the University of Alabama in Huntsville is Stanley Johns. Stan, it's good to have you here today. Today is February 8th, 2007, and I'm Charles Lundquist. Stan, can you start out by telling us a little about your youth and where you went to school and how you got into the space program?
I grew up in Youngstown, Ohio, and went to Ohio State University and got a degree in aeronautical engineering. And a couple months after I graduated, the Army sent me an induction notice, and I ended up, after basic training, I ended up being assigned to Redstone Arsenal.
What year was that?
1954. So I've been in Huntsville a long time.
Oh, tell me a little bit about your Army years, what you did while you were...
The first assignment was on the Redstone missile, doing flutter and vibration studies, where we had a full-scale Redstone hanging on springs, and shook it with vibration and whatnot. But when ABMA started with the Jupiter in '56, I got transferred to the layout area and worked on layout and mass properties on the Jupiter. And I was somewhat fortunate in that my German boss became sick.
Who was that?
Unfortunately, Gerhard Krauss. They had no one else to fulfill his duties, so I was immediately promoted to the lead configuration man.
Wow. Even
though I had a uniform on. So I really enjoyed that work, and when it came time to transfer to civil service, I just took off my uniform, and same desk, same job, same everything. But the Army neglected to transfer my security clearance to civil service status, so the first month I wasn't allowed to open my own desk and take out the paper that I generated. I couldn't look at my own work because I didn't have a security clearance.
See, the Army organization, just for the historical record, was the 9330 Technical Service Unit,
correct.
I believe.
That's correct.
And you got out of that then in '56 and took a civilian job. Well, continue telling about the Jupiter work.
So I again did the configuration and mass properties, and had to calculate all the weights and CGs for all the Jupiter nose cones, and that was very interesting work. And it was interesting in that all the different disciplines were located in one giant bullpen, the same building. And
what building was that?
I was trying to remember. It's 23, the old one-story building right on Rideout Road.
Okay, yeah.
Something 23, but anyway, it was Von Braun's headquarters also. But you never had to write a memo. If you wanted to know something, you just walked over and talked to your coworkers and got the information. And so there was no time wasted writing memos back and forth. And I particularly remember the design tactics for designing the aft unit on the Jupiter missile. It happened to be in my office, and they had all the different disciplines there, the antenna people and the reaction control people and the manufacturing people, and they drew it full scale on the center of the floor. And each discipline went around and said, I want my antennas here, and then they said, I want my reaction control here, and everybody got their inputs all at one time, and any conflicts were resolved right then. And then when they left, since the meeting was in my office, they turned to me and said, okay, you draw that up now. My job was to document all that. And the confusing part of it, some of it was in German. I didn't understand all the conversations going on. They didn't tell me this ahead of time. I was just sitting over there in the corner because it was my office. And then I got the job to draw it up. So that's how I became a big configuration man.
Well, how long did that continue?
Well, all the way, we worked on the Jupiter for 2 years, and I vividly remember, you may remember, coming to work one morning, and when the newspaper said Redstone Jupiter canceled, and I didn't know whether to turn around and go home and look for another job or go in the office, because that was when the Secretary of Defense had turned all the missile development over 200-mile range to the Air Force. And everyone assumed that that meant that Jupiter was canceled. But again, von Braun, the salesman he is, went to headquarters and convinced them that to allow the Army to continue the development of the Jupiter and then turn the operation over to the Air Force. But we were working 56 hours a week. I don't know if you were involved in that
somewhat
design, but for 2 years we just worked 56 hours a week. Very rush program, everybody's committed, and then it was all turned over to the Air Force. We never heard any more about it, and I look back and I said, well, gee, was that really worthwhile spending all that time? But after the movie 13 Days in October came out and revealed that Kennedy had used the Jupiter as a trading bond with Khrushchev to get Khrushchev to agree to remove the Russian missiles from Cuba. So it made me feel a lot better about all that time we spent, that it really had an impact on...
Well, the Jupiter vehicle, of course, was used for a number of satellite missions as the booster stage.
That's
so
correct. Yeah.
That's another very fine
worked on
use.
Junos. So.
Well, you worked on the Junos then when you finished working on the Jupiter. Well, tell us about the Juno program.
Well, again, I did the configuration of mass properties. We went out to JPL to see what the upper stage looked like. But and I one memory that on the flight out to California, some of the experts in our plane decided they were going to redesign everything on the way out there. So I didn't want to be a part of that discussion, so I hid in the back on it.
Did they actually do the redesign?
I kept far away from it. I don't know what they were talking about. I didn't want to know. I didn't.
Did the redesign?
Electronic people like
electronic people, okay.
Not the configurations.
All right, so they didn't change your part.
No. But I was a little concerned that all JPL was doing was feed me back the numbers that I was generating. I said I didn't want to see my own numbers back. I want to see their numbers. So that was interesting travel. And thinking back on the Jupiter and the contributions that von Braun made, I still vividly remember when I heard that the test stand was built 10 times bigger than it was required for the Jupiter. And I thought that was kind of extravagant. A growth factor of 10 was just kind of out of my comprehension, to go from 150,000 pound thrust engine to 1.5 million pounds. You know, in all I experienced, I couldn't comprehend numbers in the millions at this one. But then when it came time to build the Saturn, von Braun sold that program to headquarters by saying, well, we don't need any money for test stands, we already have one. All the facilities and everything were just, he was looking so far in the future to build all those facilities that were able to support the Saturn program.
Well, what did you do in the Saturn program?
Again, the initial configuration and mass properties. And I would have to go report to von Braun on the regular design meetings of what the status of the weights were. And as you know, the Saturn started out with a 2-engine configuration, then the 3-engine. It kept getting bigger and bigger as Houston increased the payload requirement to get to the moon. And finally, we got to the 5-engine configuration. And one memory of that is that the way the diameter of the booster was determined with 33 feet, you would think would be a very scientific calculation to optimize the diameter. But I remember the boss in a meeting saying, how big is the hangar's door at Michoud? Somebody says 33 feet. So he says, well, we'll just make it as big as it can fit through the door, and then we'll never have to go back and say we should have made it bigger. A very practical.
What organization were you in at this time, by the time the Saturn program? What?
Well, this was all the, the propulsion vehicle engineering laboratory.
Who was the lab director at that time?
Dr. Maratzik.
Maratzik, all right.
Dr. Maratzik.
Maratzik was an interesting character.
He was outstanding.
Well, any more tales about the Saturn program as it went along and developed? Any more thoughts about it?
Well, when the mode selection, when they first made the determination of the mode to get to the moon, where they were going to use 2 launches, an Earth orbit rendezvous, and then go on to the moon, which is the von Braun favorite, or the lunar orbit rendezvous, and then there was a NOVA program, a giant booster. That configuration was one of the contenders, and then I remember that the preliminary design group at Marshall was supporting a contractor proposal for a single launch direct to the moon, direct landing, a C5 directing. And I had called to Washington with my boss to evaluate the contractor's proposal from a weight and configuration standpoint. And the weights were so optimistic beyond the state of the art that had never been done before. They had real high mass fractions. And so a week up there, I said, well, I think it's too risky. It's not practical to go with that design. And so my boss called back through the head of the preliminary design here at Marshall, and his response was he was going to report me to von Braun for sabotaging this country's only opportunity to beat the Russians to the moon.
Oh.
So I was a little concerned. But everybody accepted my evaluation. So
I'm sure Werner would have accepted it too, or did accept it.
So the contractor was too optimistic. They were just... I used to go... because we did a lot of the analysis, engineering analysis in-house. We knew more about the configurations than the contractors did at that time. And on later trips out to the contractor, I would try to find the individual who would put down these optimistic weights. And it looked like their format that they had taken from one of their vehicles. And they had separation rockets in there, and our estimate, or our calculation, said we had, the first stage had to have 5,000 pounds of retromotors to keep the booster from running into the second stage of separation. And the contractor said they only needed 500 pounds. I said, how did you do that? He said, well, our vehicle only needed 5 pounds, or maybe it was 50, and he upped it to 500. He just put a fudge factor on it. They never did any analysis, so that made me very suspicious of some of these proposals, that you had to really check it out.
Yeah.
They were just giving you a sales pitch, or whether they really knew what they had there.
Well, what was your involvement during the flights of the Saturn?
Well,
involved in checking how it worked, or what?
No, because see, my role was basically in the preliminary design. And once you had critical design review and the drawings were all released for fabrication, we moved on to the next program. And
okay, and what was that?
Turned it over to the other group. Well, we started on human factors, and the first major project that we started out was a moon room simulator that our group identified an old storage tank on the Arsenal that had been abandoned, and we said, well, we want to use that to paint it black inside and put a lunar surface, and we're going to do pressure-suited astronaut simulations of the lunar surface experiments that were being developed here. And so we had to develop some expertise because we didn't really have the experience in human factors. So we were fortunate to find a supporter in headquarters that we would submit supporting research and technology proposals to do simulations and research of manned pressure suit activities. And we would get funding then to go out and buy the best contractor experts to support contract who had the expertise and who would do these experiments and at the same time train our people to how to do this, how to function. And we found out that, you know, in trying to convince the astronauts and Houston of our human factors design, that we couldn't just give our opinion, because we didn't really have, weren't recognized as experts. We had to give them simulation data and experimental data to actually demonstrate how the hardware worked with the interfaces. And that developed from the moon room. Well, actually, Jack Schmidt, who was the last astronaut mission to Apollo, who was the geologist, came to visit the moon room and go through, observe our simulations before he was ever selected for the astronaut corps. So I always, you know, I knew him before he was even an astronaut.
This was while he was at Harvard?
No, he was at out there with Shoemaker at.
Oh, okay. In Arizona.
Arizona, yeah.
Or was it?
Yeah, it was Arizona. What was it?
Flagstaff.
Flagstaff.
Yeah. All right.
He was working out there.
Well,
Shoemaker
I knew
came
him.
with him.
I knew him when he was a student at Harvard.
Oh, wow! you really go back then. So.
What organization was it that was you were in at the time?
We had an advanced studies group at that time, and it was just initially formed, this human factors group, and that was really a wonderful experience because I was selected to head up the group with no employees. I was a one-man organization, so then I had the opportunity to go out and solicit all my staff and crew, and which was fortunate that I could find experts that weren't being utilized in that area, like an ex-Air Force, retired Air Force pilot that had worked at Wright Field in human factors, was working in the propulsion group, so I managed to persuade him to request a transfer, and a few other people that I just have to beg, borrow, and steal people wherever I could get them. Because we didn't even have the authority to hire human factors people initially. We had to go to personnel and convince them to generate job descriptions and job categories for people who had that kind of talent and interest.
How large did the group get eventually?
About 20 human factors people.
That's quite an organization.
And yeah, and then we had a lot of support contractors on. We had Brown Engineering doing work, and we had the people that came in from California to do the lunar driving simulator. We got an SRT study to do driving on the lunar surface with the pressure suit, with a hand controller, developed a hand controller, and we were lucky to get the support of the Comp Lab, who had a moving base simulator that they were looking for contract support justification to go ahead and do that work. And again, I had to sell the Comp Lab guy that was the thing to do, and it was a use for it and a mission. Because none of these projects were ever assigned, because I remember when farther down the road, an example where the new management would say, "Who told you to do that?" I said, "Well, nobody ever told us to do it. If we had to wait for somebody to tell us, it would be too late." It was a wonderful opportunity because we were just kind of on our own, and we were just.
Well, how much of this work was used, say, in the lunar roving vehicle?
Well, I was actually that's how the lunar rover. I like to speculate that the reason the Marshall was given that project is that we had the simulation capability to develop the hand controller. And they had, rocks, visual, that the astronaut would be sitting there with the hand controller, and they had a visual simulation. He'd drive around the rocks and figure out what kind of gains on the power steering. You had low gain and high gain in order to drive, and how fast he could drive. And that was
so
critical.
That the control then of the lunar roving vehicle grew out of the preliminary work you did.
That's right, absolutely.
Oh, very good.
And the same way then with the ATM on Skylab, the ATM controls and displays, which are very critical human factors interface, where on the Apollo telescope mount on Skylab, where the experiments were to take pictures of solar flares on the sun's surface, and the astronaut had 30 seconds to point the cameras. When he'd see a solar flare, he'd have to direct the cameras with a control stick to take photographs of the flare, because they wanted to collect data that would allow them to predict solar flares and the intensity. So because in those days there wasn't enough radiation protection on the spacecraft, and that the crew would actually have to abort and come back to Earth if there was an intense solar flare. So that was a serious thing, and it was quite a intense design reviews, instructions with the astronauts and with Houston. That's where we really had the first crew station reviews that would come up here to Marshall with their whole how to handle that, and we had to provide the famous RID forms, which review item discrepancies, which was a new process for Marshall to provide all these review items that had to be resolved in these design reviews. That Houston would track them all and everything. So it was a new discipline, a new procedures and new operations for Marshall, and it was never widely publicized because I think a lot of the old management was concerned that they would cause controversy with Houston, that we were getting too much into the human factors design of spacecraft. They thought that was their own private area.
Who were some of your main colleagues in this human factors work?
Well, my deputy was Mike Vaccaro, who was very instrumental, and he was responsible. He went to a meeting at Houston, and by his outstanding personality, persuaded Houston to provide us 2 surplus pressure suits. We never went through channels, and we never got any approval or anything. He just kind of surplus those pressure suits under the table, which that was our key to getting into the human factors, because without the pressure suits we would have been dead in the water, essentially.
Who else was there?
Yeah, well, I mentioned the Air Force pilot was Hayden Grubbs, who had a lot of, human factors experience with the Air Force, and then we were also fortunate that an individual, Bob McBrayer, who was working in human factors at Houston, who for family considerations wanted to transfer to Marshall. So the Houston people contacted us and told us that they had an employee, a really good employee, who wanted to transfer, and they said, well, we're happy we take him. So we managed to get one that way on a transfer. And we would recruit, another one, Dick Heckman was a key player, who was a support contractor, and convinced him to take a pay cut to come to work for NASA, and fortunately he did. So, I felt my major role was a salesman. I had to sell headquarters, I had to sell employees, I had to sell the management, and I had a good team that would generate all these wonderful ideas and projects. So I wasn't afraid to stick my neck out. And
that's an admirable role, I must say, and a historic role for that matter.
Well, I've often wondered, that like a story on the ATM control and display simulation in the comp lab again. When we built that, we put in training capability, which is you had malfunctions, and then the astronaut would correct for that. And I remember the Houston counterpart saying that Houston didn't want their hardware developers to build trainers. They always built their own trainers after the hardware was built. And in those days, where you had the technical responsibility, well, I could make the decision. I said, well, we're going to do it anyway, because you can't add it on later. We have to. So the interesting thing was that when it came time to train the astronauts, they didn't have enough time to build a trainer. They had to come up here to the comp lab to do their training, but they wouldn't call it training. It was called procedures development.
So did all the Skylab astronauts come up and get trained?
Yeah. They got trained here on the Comp Lab training simulator. Well, what they call it, training simulator. Procedures development.
Did you get to know some of them pretty well?
Oh, absolutely. We've had astronauts that come to the house for dinner. My wife likes to tell the stories where I'd call her at 10 o'clock in the morning, honey, I'd like to bring home 2 astronauts for dinner. She says, well, we had 2 little babies, you know. She didn't know whether she could handle it. We just moved into our house, didn't have any living room furniture or anything. So she can tell you a lot of stories about.
You should do an interview with her then.
Her favorite astronaut was Bruce McCandless, because he was concerned about our baby crawling up the stairs from the bottom up when we had to eat in the kitchen. And he says, stop, your baby's crawling up the stairs. My wife says, it does it all the time. So we finally says, stop. He says, I can't. He couldn't stand it. He had to go down and put his finger out to help the baby come up the stairs. He's afraid he's going to fall. So, my wife said it was like a snapshot. Here's a man who's going to fly in space, and he's worried about a baby falling down the stairs. She thought that was really something.
That's an admirable trait, really.
So we got to be pretty friendly with several of the Skylab astronauts, and then the German astronaut trained here at Marshall for on Skylab with Mulbo. And he just lived on our street, but we didn't get to see him very often because he was so busy. But
well, after Skylab, what did you get involved in?
Let me think. I guess
the Apollo
Space Lab. Well, you know, it's
ASTP, the Russian
APP. I mean, Apollo. No.
Apollo Soyuz.
Actually, the main thing was Space Lab was a payload for the shuttle.
All right.
And we got transferred over there to in the interim, I spent with Central Systems Engineering. I spent some time in the Space Station Division because after Skylab, I wanted to move on to the next big program, and so I was in the Space Station Division, and that was interesting because we were going to launch a big Saturn V launch space station, but then that funding fell through on that.
Who headed that activity?
Well, Conrad Dannenberg was doing the space station work.
Well, Connie was doing that. Good.
And we did a lot of interface with Houston on requirements for space station, and it was a fun project because I always wanted to move on to the new projects after the configuration, design, and decision made. I wanted to go on to the next challenge. And then Space Lab came along, and it was particularly interesting to work with all the different European engineers with the European Space Agency. And I always thought it was interesting the way the Europeans worked on Space Lab, in that instead of like we do, going to the lowest bidder, the lowest contractor for the different work, they would allocate their contracts back to the countries that contributed the money. Like Germany contributed 50% of the money, so their contractors got 50% of the contracts, and they would allocate that to the whatever the capability was. And France had such. Italy had 25%. They did all the structures. Germany did the integration. France did the computers. And it was when they got down to some of the smaller countries like Spain, they had a hard time finding companies to utilize the money that had the technical capability. So I think Spain ended up with the ground support, transport equipment, things like that. And they had light fixtures. They gave them the light fixtures. And the interesting thing with the Europeans on Space Lab, they were very adamant about not using U.S. hardware. They wanted all the money to go back to Europe. I heard the Eastern Managing Slip said no way would they have an IBM computer in the European Space Lab. So the politics involved. And the same thing was with the light bulbs, for the interior light bulbs. And the problem was, though, when they wanted Philips to build the light bulbs, but they no bid it because they couldn't meet the safety requirements of the mercury in the bulbs. And so they ended up having to come back and buy Westinghouse bulbs anyway.
Now, that must have been hard for them. So what came along after Space Lab?
Well, that was my last, I spent 15 years on Space Lab, and then I retired. Oh. And in the end, it was, again, interesting in that I was the Space Lab representative on the Flight Assignment Working Group, which determined the flight frequency and schedule for all the Space Lab missions in combination with all the other missions. And so we had to figure out the hardware availability to turn around one set of hardware from one mission to the next, and when and what racks would we fly, and would we have enough hardware, and this is a general logistics effort on all the space.
So you were in the Space Lab organization at that time?
I was a charter member of the program office.
The program office.
Okay. I ended up getting transferred to the program office.
Okay, so you were in the Space Lab program office. Yeah. Who, Jack Lee headed that at that time?
Yeah. Well, I was there before he was there.
Oh, you were there before. Who headed it first?
I can't remember the guy's name now.
Okay. Don't worry about it.
It'll come to me, Jack somebody, but...
Okay. Well, and then you retired. What year did you retire?
I retired in '85, and then I went to work for Brown Engineering.
So you work? Are you still working, or?
No. I worked for Brown for 10 years, and then I retired again. So I had a cash flow problem with 2 kids in college.
Oh, yeah.
And I borrowed all the money, and I said, I need to supplement my income. So I go to work with the contractor, because it was a wonderful retirement job, because I would find problems, and I go to NASA and says, you guys got a problem. When I worked with NASA, they always wanted me to fix the problem. Mm-hmm. And it always took money to fix it. And nobody wanted to spend money, so I could go home and forget about the problems when I worked for the contractor.
Well, do you have any final thoughts you'd like to leave with the new generation of employees that are coming along and have to do?
I picked up some insight from Von Braun that I think are very valuable, in that how he really instilled the team spirit in every employee, and I think he did that by holding each individual felt responsible for what they generated, their number. And you never, because you knew that you had to be prepared to go defend your numbers to Von Braun, because his policy was to hear the presentations from the engineer who did the work. He didn't want to hear from the bosses. He wanted to hear from you. So that put everybody on their toes. And you knew that if you didn't know the help, one nice advantage, and I found in government service, that if you needed help, you could go talk to anybody, and everybody would help you. They didn't say they didn't have time or were too busy, and then plus the fact that you got a lot of different experience, because it was just like changing projects or companies. If you're in private industry, or you're moving all around the country, where we could have so many different challenging job assignments by staying in one place right here in Huntsville. And the thing that kind of concerned me, if I had some advice for college graduates, is that when you work, it's not like going to school. Because I've run into students who bring you a piece of paper, they think it's like taking an exam. If they don't know the answer, they'll write something down anyway, just trying to get, and they think I'm the teacher, and I'm going to find all their mistakes and grade it and hand it back to them. And I said, that's not the way it works in industry. If you write it down, you better know that's a fact. If you don't know the information, you go ask. And they seem to, the new employees seem to be very reluctant to admit they don't know something and want to go ask. And I said, that's the way it is. And the other thing from Von Braun is that he invited problems. He wanted to hear problems. He said his role was to solve problems. And I was in a meeting where he invited all the lab directors to bring their problems to him, and he would put the total resources of the center solving those problems. And unfortunately, I run into managers that don't want to be problem solvers. They don't want to hear problems. So that's a big contrast with the von Braun approach. And I think they keep talking about regenerating the NASA mode of operation, and I think what they really mean is going back to the von Braun way of operating.
That's very good advice for the new folks who are trying to redo some of the things you did.
Yeah. And too many people want the computer to do everything. They would they would program the computer would run, they thought they did their job but it didn't give them the right answer. They don't go through to verify the handwork to verify that the computer answer is correct. And you have to go back, and then you find out, well, they made some bad assumptions. They put in the wrong data, you know. And they need to know that
garbage in, garbage out. Huh?
You have to verify your answers, make sure that you get the computer's giving you the right answer.
Well, I guess in summary, you'd say you had a good career.
Oh, it was outstanding. I think it was marvelous. You know, how fortunate one can be is to end up in Huntsville and to work with the von Braun team. It's the premier engineering organization, and every day was exciting and challenging, and wonderful co-workers, and you couldn't ask for a better career. And I, you know, it's kind of sad today when you think that when my son doesn't get to experience that type of excitement and challenge and interest. I think those days are gone. I think there's more complexity. When von Braun, going back to the Jupiter, the first design review I was in with von Braun was where there were competing design. We got a mock-up review of the Jupiter instrument section of how to install the instruments in terms of access and manufacturing and everything else. And so he would hear everybody's presentation, and then he would summarize and give his assessment. And then he would give always give in his meetings, he would always give the rationale of how he arrived at that decision, so that everybody in the room was getting that much smarter. So the next time you would know the proper philosophy to apply. And the thing that amazed me when he got done is that he had all these people standing around, and he had all his laboratory directors there, and he would just point to each one like this, and they all had a chance to express their opinion if they had a problem with his decision or wanted to add anything. And he got each one to nod their head, and you could leave that meeting with everybody on the same page, and you knew why you were having the decision. You go, and things don't operate like that anymore. You got too many committees, too many levels of communication.
Well, that's a good way to end the interview. We surely thank you for being here today, Stan, and wish you well.
Thank you very much.